Hello students, good morning everyone. Today let us see Lagrange's mean value theorem as well as Rolle's theorem. Here only a slight difference. Here f of a may not be necessarily not be equal to f of b. That's all. The same way let f of b a function, f of x be a function. Then we want to check whether f of x is continuous on the given interval a comma b, closed interval. Next condition is f of x is differentiable on open interval a comma b. It is closed interval, it is open interval, and the f of a may not be equal to f of b. May or may not be equal. If it is equal, it is rotated Rolle's theorem. It is known as rotated Rolle's theorem. If it is not equal, let us conclude that there exists at least one point. There exists at least one point C which belongs to open interval a comma b. Then such that we can write it as f dash of c is equal to, in Rolle's theorem we have taken f dash of c equal to 0. Here f dash of c equal to f of b minus f of a divided by b minus a. That is, if we take a curve like this, and if it is a tangent, then it makes a slope at the point, and here it makes f of a, that is, here it is a point x is equal to a, and here it is a point x is equal to e, x is equal to b, and there exists another point, it is x is equal to a. So if we want to find the slope f dash of c, there exists a point c, that is the differentiation rate of change of c, that gives us the slope, and which is equal to, we can say that the average value of, that is f of b minus f of a by b minus a. So this is mean value theorem. By using this theorem, let us solve some of the problems. Now exercise 7.3, question number 4. Using Lagrange's mean value theorem, determine the values of x at which the tangent is parallel to the secant line at the endpoints of the given interval. First subdivision, f of x is equal to x square minus 3x plus 2, where x belongs to closed interval minus 2 comma 2. So it is f of x is equal to x cube minus 3x plus 2, where x belongs to closed interval minus 2 comma 2. First let us check, since it is a polynomial, we can say that f of x is continuous on closed interval minus 2 comma 2. First condition satisfied. The second condition, if it is differentiable or not. So f of x is differentiable on open interval minus 2 comma 2. So since it is a polynomial, it is differentiable. Then find the f of a. F of a equal to f of minus 2. So substitute here minus 2 the whole cube minus 3 into minus 2 plus 2. So it is minus 8 plus 6 plus 2 equal to 0. Then f of b equal to f of 2, which is equal to 2 the whole cube minus 3 into 2 plus 2. இதில் xக்கு பதிலாக 2 substitute பண்ணுறோம். So it is 8 minus 6 plus 2, 10 minus 6, 4. Say these two are not equal. So may not be equal, the condition கொடுத்துருக்காங்க. Hence mean value theorem exists, and by mean value theorem we want to find f dash of x is equal to, இதை differentiate பண்ணிக்கோங்க, x cube differentiate பண்ணா 3x square minus 3x differentiate பண்ணா 3, 2 differentiate பண்ணா 0. So f dash of x கிடைச்சாச்சு. Now by mean value theorem, f dash of c equal to f of b minus f of a by b minus a is the formula. Now the f dash of c na remove x by c. There exists a point c, therefore f dash of c equal to 3c square minus 3. Now substitute here f dash of c. So 3c square minus 3 is equal to f of b is 4 minus f of a is 0. b is 2 minus a is minus 2. So which becomes 4 by 4 equal to 1. So 3c square minus 3 equal to 1. 3c square equal to 1 plus 3 equal to 4. So c square equal to 4 by 3. Therefore c is equal to plus or minus 2 by root 3. Now these two belongs to the given interval. Two values are there. So two values belongs to the interval minus 2 comma 2, and hence the value of c is plus or minus 2 by root 3. Then question number 2, second subdivision. Now second subdivision, f of x is equal to x minus 2 into x minus 7, where x belongs to closed interval 3 comma 11. Let us first if it is continuous or not check. F of x is continuous on closed interval 3 comma 11. Next, f of x is differentiable on open interval 3 comma 11. So two conditions satisfied, hence mean value theorem exists. Then we want to check f of a is equal to f of 3 is equal to 3 minus 2, 3 minus 7, 3 minus 2 is 1, it is minus 4, so which is equal to minus 4. Then f of b equal to f of 11 equal to 11 minus 2 into 11 minus 4. 11 minus 2 is 9, 11 minus 7 is 4, which is equal to 36. So these two are not equal. So here we don't bother about this condition. Now let us find out f of x, f dash of x. Let me write f of x in this form. It is given in linear factors. Now multiply these two, we will get x square minus 7x minus 2x minus 9x plus 14. So differentiate, it is very easy to differentiate. Now find the f dash of x. 2x minus 9. X square differentiate panna 2x minus 9x differentiate panna minus 9. 14 differentiate panna 0. If there exists a point c, therefore f dash of c equal to 2c minus 9. Now by mean value theorem, we have the formula f dash of c equal to f of b minus f of a by b minus a. F dash of c is 2c minus 9 is equal to f of b is 36 minus f of a is minus 4 divided by b minus a. This is a comma b. So b is 11 minus 3. So 2c minus 9 equal to 36 minus minus plus 36 plus 4 40 divided by 11 minus 3 8. Let me cancel this. This is 5 times. So 2c minus 9 equal to 5. 2c equal to 5 plus 9 equal to 14. So c equal to 14 by 2 equal to 7. So c equal to 7. In the 7, 3,11 interval irukanu check pananum. Yes, definitely it lies between 3 and 11. So take a open interval 3,11. So it belongs to 3,11. Hence the answer is C equal to 7. Then question number 5. Now question number 5. Show that the value in the conclusion of the mean value theorem for first subdivision f of x is equal to 1 by x on a closed interval of positive numbers, closed interval a comma b is root ab. Now let me take the function at first subdivision. F of x is equal to 1 by x where x belongs to closed interval a comma b. So we want to find the c is equal to square root of ab. Let us find that. Now let me check the two conditions at first. F of x is continuous or not. Yes, since it is a polynomial, it is continuous on closed interval a comma b. If it is differentiable or not, it is differentiable definitely. So it is differentiable on open interval a comma b. Now let me find f of a is equal to, instead of x, substitute a, it is 1 by a. F of b equal to 1 by b. Now find the f dash of x. For that I am writing f of x is equal to 1 by x. So f dash of x is equal to, so while differentiating this we are getting minus 1 by x square. 1 by x differentiate panna minus 1 by x square. Then there exists a point c, therefore remove x by c, we are getting f dash of c equal to minus 1 by c square. Now let us apply in mean value theorem. So by mean value theorem, the formula is f dash of c equal to f of b minus f of a divided by b minus a. F dash of c is minus 1 by c square is equal to f of b is 1 by b minus 1 by a by this b minus a. Now take LCM in the numerator and solve. It is left hand side minus 1 by c square. LCM ab cross multiply a minus b by b minus a. So now take this reciprocal, it becomes ab into b minus a. So minus 1 by c square equal to a minus b by ab into b minus a. Now to cancel these two, take a minus value out. Therefore take a minus common number, then it becomes b minus a. Minus minus plus, plus b minus a into ab into b minus a. So if I cancel these two, I am getting minus 1 by c square equal to minus 1 by ab. Cancel this minus value, then c square is equal to ab. So therefore c is equal to plus or minus root of ab. Now since the interval is in positive, we are getting only the positive answer. So which implies c is equal to minus root ab does not belongs to the interval a comma b. Therefore c equal to square root of ab positive belongs to a comma b is the answer. Then second subdivision. F of x is equal to capital A x square plus capital B x plus capital C, where x belongs to closed interval a comma b, and we want to prove that the c value is a plus b by 2, small a plus small b by 2. Now let us continue this. Now first f of x is continuous on a comma b. Since it is a polynomial, f of x is differentiable on open interval a comma b. Find f of a equal to, இப்போ x க்கு பதிலா a, capital A, x க்கு பதிலா a போட்டா a square plus capital B, small a plus c. Now f of b equal to capital A b square plus capital B b plus c. Now these two are not equal and I want to find f dash of x. For that f of x equal to ax square plus bx plus c ன்னு எழுதிக்கிட்டு f dash of x x square differentiate பண்ணா a is a constant அப்படியே எழுதிப்போம். x square differentiate பண்ணா 2x, so a into 2x plus b is a constant, x differentiate பண்ணா 1, so c differentiate பண்ணா 0, so 2ax plus b. If there exists a number c, therefore it becomes f dash of c equal to 2ac plus b. Now by mean value theorem, f dash of c equal to f of b minus f of a divided by b minus a. F dash of c 2ac plus b is equal to f of b is a b square plus b plus c minus f of a. Take a bracket and write a square plus ba plus c divided by b minus a. Now remove the bracket and write. So it is left hand side 2ac plus b is equal to ab square plus bb plus c minus a square minus ba minus c divided by b minus a. Now c get cancelled. Now grouping, a is a common factor, here b square and a square, so it is b square minus a square. இந்த ரெண்டுலையும் a காமனா எடுத்துட்டோம், அடுத்து இருக்கிறதுல b காமனா எடுக்கிறோம், so it is b and a, so b minus a divided by b minus a. Now split this into b plus a and b minus a, so 2ac plus b is equal to a of b plus a into b minus a plus b into b minus a divided by b minus a. Now take the common factor out, 2ac plus b is equal to, so common factor b minus a. இதை வெளியே எடுத்துட்டா பேலன்ஸ் a into b plus a பேலன்ஸ், bல இருக்கிற b minus a வெளியே போயிடுச்சு, பேலன்ஸ் b divided by b minus a. Now these two get cancelled. Now it is 2ac plus b is equal to a of b plus a plus b is remaining. Now plus b and this b get cancelled. Therefore 2c, so here c is equal to 2ac equal to a into b plus a, so c equal to a into b plus a by 2a. Now a get cancelled, so c is equal to, so which implies since it is positive we can write a plus b by 2 is the answer, hence proved. Now let's go to the next problem. Now question number 6. A race car driver is racing at 20th kilometer. If his speed never exceeds 150 kilometer per hour, what is the maximum distance he can cover in the next 2 hours? So first ஆரம்பிக்கும் போது time is equal to t is equal to 0 அப்படின்னு எடுத்துக்கலாம். அப்போ when t equal to 0, அவர் எந்த கிலோமீட்டர்ல இருந்தார் அப்படின்னா 20th கிலோமீட்டர். So I can take it as when t equal to 0, function f of t is equal to 20. F of t equal to 20. When t equal to 2, f of t is equal to what? We want to find f of t. That is f of t is equal to, here I can write f of 0 equal to 20. I can write this as f of 2 equal to what? Before that, I want to take f of t be the distance traveled by the, let f of t be the distance traveled. Distance traveled by a race car driver in t hours. Hours in t hours. Therefore, when t equal to 0, first you write this, then you write these two conditions. And I can take f dash of t can be the speed. That is speed. Here it is given speed is not more than or equal to 150 km per hour. Speed is more than or equal to 150 km per hour. Not exceed. So f dash of t must not be exceeds 150 km per hour. So இதோட கூட வரக்கூடாது அப்படின்னு கண்டிஷன் கொடுத்திருக்காங்க. Now let us write by mean value theorem. F of t is continuous on closed interval 0, 2. T equal to 0, t equal to 2 கொடுத்திருக்காங்க. So interval இப்படி எடுத்துக்கோங்க. Next, f of t is differentiable on open interval 0, 2 and f of 0 is equal to 20. F of 2 is equal to what? This is what we want to find. And by mean value theorem, f dash of t. Here straight away I am going to take t is equal to f of b minus f of a divided by b minus a, or you can take c and you take f dash of t is equal to f of b. F of b is f of 2 minus f of 0 divided by 2 minus 0 is not more than 150 km per hour. So I am taking the inequality like this. So f of 2 is equal to, so which implies f of 2 I don't know, minus f of 0 is 20 divided by 2 greater than or equal to 150. Now bring this to this side. So it becomes f of 2 minus 20 more than 300. So f of 2 is greater than 300 plus 20. So f of 2 is greater than or equal to 320 km. That is, it should not exceed more than 150, means the answer is f of 2 is equal to 300 km is the answer. So when at time t 2 hours, the race car driver speeds into 300th kilometer is the answer. Then question number 7. Now question number 7. Suppose that for a function f of x, f dash of x less than or equal to 1, for all 1 less than or equal to x less than or equal to 4, show that f of 4 minus f of 1 less than or equal to 3. So what is given here? Very simple. Given f of x is less than or equal to 1. For all 1 less than or equal to x less than or equal to 4. So the interval is 1, 4. Now by mean value theorem, we can take f dash of c equal to f of b minus f of a by b minus a. Before that we can write f of x is continuous and f of x is differentiable. Now f dash of c, that is f dash of x here, is equal to f of b is f of 4 minus f of 1 divided by b minus a, and f dash of x is less than or equal to 1, it is given. Now f of 4 minus, what is b minus a, what is b and what is a. Now let me substitute here, f of 4 minus f of 1 by 4 minus 1 less than or equal to 1. So it is 3. So f of 4 minus f of 1 less than or equal to 3. Hence proved. So it is what to be proved. Now go to the 8th question. Now 8th question, does there exist a differentiable function f of x such that f of 0 equal to minus 1, f of 2 equal to 4 and f dash of x less than or equal to 2 for all x. So here it is given f of x, f dash of x is less than or equal to 2. So given f dash of x is less than or equal to 2. So question number 7 also, f dash of x less than or equal to 1. Here f dash of x less than or equal to 2 and it is given f of 0 equal to minus 1, f of 2 equal to 4. So f of x is continuous and f of x is differentiable, everything is applied. So by mean value theorem we can go f dash of c equal to f of b minus f of a divided by b minus a. F dash of c is here f dash of x, that is f of b is f of 2 minus f of 0, take it as a intervals, divide by 2 minus 0 is less than or equal to 2, it is given. Now f of 2 is 4 minus 1 divided by 2 less than or equal to 2. So is it possible? 4 plus 1 is 5, 5 by 2 less than or equal to 2. If I take it as a decimal, it becomes 2.5 is not less than or equal to 2. 2 oda periya number. So there should be no point exist in the given interval 0, 2. So C is equal to 2.5 does not belongs to the interval 0, 2 is the answer. Then go to the next question. Now question number 9. Show that there lies a point on the curve f of x is equal to x into x plus 3 into e power minus pi by 2, where minus 3 less than or equal to x less than or equal to 0, where tangent drawn in is parallel to the x-axis. So we want to show that yes, there is a tangent drawn parallel to x-axis. So for that, first let me take f of x is equal to x into x plus 3 into e power minus pi by 2, where the limit is minus 3 less than or equal to x less than or equal to 0. So minus 3, 0. Let me take at as f of x is continuous on the given interval minus 3, 0 and f of x is differentiable on minus 3, 0 and take f of a equal to f of minus 3 equal to minus 3 into minus 3 plus 3 into e power minus pi by 2 equal to 0. Then f of b equal to f of 0. Minus 3 plus 3 is 0, 0 into anything is 0. So f of 0 is 0 into 0 plus 3 into e power minus pi by 2 equal to 0 into anything is 0. So these two are equal. So it turns into its Rolle's theorem. Therefore I can write. So Rolle's theorem exists, I can write. Therefore Rolle's theorem exists. Or you can go for mean value theorem also, then also you can get the answer. Rolle's theorem exists. So there exists a point C C belongs to minus 3 comma 0. Then take f of x is equal to, now multiply this x inside and write x square plus 3x into e power minus pi by 2. Now take this as a constant. So you differentiate this function. F dash of x is equal to x square differentiate panna 2x plus 3x differentiate panna 3 into e power minus pi by 2. So by Rolle's theorem, we want to take f dash of c is equal to, இதுல x remove பண்ணி c போடுங்க. So 2c plus 3 into e power minus pi by 2 is equal to 0. Rolle's theorem nala f dash of c equal to 0. So which implies 2c plus 3 equal to 0. Since it is a constant, in the side varumbodhu 0. So 2c equal to minus 3, c equal to minus 3 by 2. In the minus 3 by 2 in the interval line iruka? Yes. So c is equal to minus 3 by 2 belongs to minus 3 comma 0. So the value of c is this one. Thank you. And 10th sum is homework for you. It is very easy. You can do by yourself. Thank you.